I'm here with Dr. Romano, and we're going to be doing an organic chemistry sequence reaction that's very tricky for the DAT.
Come on around. Let's take a look at a problem that I devised for the study group. This is not a question for a kid that's getting an 18 or a 19, but this is going for the kids that is going for the 25 to 30 range. What I did is I'm going to start with this compound, and I want to figure out what letter D is. And I'm going to be treating it with all these different reagents and get these intermediate products along the way. The first thing I do is I notice I have a carboxylic acid, but at the far left of the molecule, we had a carbonyl group that's been protected. So this group, which is called an acetal linkage, which is another good question for the DAT, this is an acetal linkage. This is our protecting group. So we've protected a carbonyl group. In the first step, we're going to take SOCl2, and what that's going to do is going to replace the OH with a Cl. Then we're going to treat this with CH3OH. The Cl comes off, and the OCH3 comes on, and we install an ester. So letter A, we have a protected ester now created from a carboxylic acid that's been protected. The next step is LDA, which is a very strong, bulky base. And what that's going to do, it's going to remove off the alpha hydrogens. And we're going to form an ester enolate. So remember that word. We got the word enolate when we remove the alpha hydrogen. Now, step number 2 is a reagent you might not have ever come across. All it is a nucleophile. So what we're going to simply do is we're going to launch an attack. We're going to take the sulfur, and this group will leave me. And we would put on our sulfide moiety. So now we've alkylated the molecule, or I should say we've added a sulfide moiety to the molecule, and we've now created letter B. Now it gets a little tricky. What does H3O do? Now there's no heat, so it's not going to cleave the ester group, but what it will do is it will gently take off the protecting group, and that would give me letter C. And then NaIO4, which is sodium periodate, is something you might not have seen. This is an oxidizing agent, and it would work just like hydrogen peroxide, and that will convert the sulfide group, which is also called a thioether. It will oxidize it into a sulfoxide. All right. If you manage to get that far, the last step is the grand finale and the trickiest. If you ever heat a sulfoxide group that is adjacent to a carbonyl group, it's going to undergo an elimination. So that would mean that this and this will eliminate, and you would install the double bond, and that would give you a conjugated system, which would be the driving force here. I hope this gives you a good idea of what we're looking for in a sequence. You're probably not going to see anything this challenging on the DAT, but I always like to do a little overkill so we can hit that 30. This summer we had an enormous amount of 30s in our book, so any bullshit you hear about overkill, ignore that. It's just made for those that's trying to deceive you to do something like buy a video or something like that. So ignore anything about overkill. You make sure you learn these reactions, and you'll be able to hit that 30, and then we'll see what overkill really means. All right, good day to you. I hope this clears things up. Bye-bye.